here today to dispel some myths about carbon capture and sequestration. And one of the things we've been hearing a lot of is this idea that when we're sequestering, we're going after big caverns in the ground, big salt domes, things like that. And what we're trying to show is really the science behind what we're really doing in this system. So a lot of people have this idea and they're concerned because they're thinking bayou corn, they're thinking salt domes, they're thinking like big caverns. And so we're trying to show that's not how this injection works. We're injecting into rocks, like oil and gas. Like this sort of comes from, yeah, exactly. So we're showing this is how that system works, not this big cavern, nothing like that. CO2 will be going into pore spaces, tiny little microscopic pore spaces, and what you're looking for are reservoirs that have lots of porosity and it's permeable, that fluids can flow through those pores easily. And so the seal is completely impermeable. No fluids get through it. There's no space in the rocks for fluids to get through there, basically. So there's two concepts, porosity and permeability. Porosity is the little space in between the grains of sand. Permeability is how well those spaces are connected, because that's how well things can actually flow through the rock. You want to push down on that green one real quick.
So this is your most permeable?
This is the most permeable. So it's pretty easy to push stuff through it.
Oh, wow.
It's really easy to move fluids in there, and that's what we're looking for in a reservoir.
Yeah, try it out.
So even though you can't see the spaces, they're there.
Yeah, there's a lot of them.
Try the blue one next. Still easy, but a little bit harder, right? Now try the blue one. It should be similar, but a little bit harder, right?
Ooh, I want to try it.
A little bit harder. It takes a little bit more pressure, so the permeability is lower here. It's still a decent reservoir. Now try this one.
Thanks. I feel it's going to take a lot of effort. Oh, dang.
So it's still a reservoir, but it's not a seal. Things can get through, but it's much harder, isn't it?
Yeah, it takes a lot of effort.
And they get less permeable. Less and less can get through it. And so for a full-on seal, like every sequestration project has to prove they have in their system, you have to have a reservoir covered by a cap rock or a seal to keep all the CO2 in place. You can't pump CO2 through your seal. And this is just kind of the science behind how that really works. So we have to make sure inside now that we have a good cap rock and we have a good reservoir, or you don't have a project. So it just fits through, even though you can't see the pores, they're there.
Right, because the air came out.
Exactly.
I think this would help people understand. That's why I was like, this is really cool. This is my first seeing it.
To make sure that we know exactly what's going on there, and to make sure we've got all the parts of the system we need, we take cores, and this is actually one from a gas field in offshore Louisiana, from the same unit we'll be looking at. And we'll be taking cores like this, and then we take samples out of those cores, and we basically test them in the lab to see exactly how porous and how permeable they get. This is a real core from a well offshore Louisiana.
I think this is great. Like you go to every community in Louisiana with this display and sell it. Like, here's how it's working.
You're more than welcome to call us or email us. My name's Mariel. If you say I'm the only Mariel and I'm the only geologist, so you'll find.